Assalamu alaikum. Our final year project is Shajr Stats. My team is Syed Mohammad Saleh Ali, Mohammad Mas Tariq, and our supervisor, Dr. Tariq Mahmood. Our project, Shajr Stats, is basically part of the environment monitoring module of NED RCI Labs CityPulse Mega Portal project. Their project is working towards urban data visualization and analysis. Shajr Stats is an interactive web application that provides quantifiable information about levels of vegetation throughout Pakistan, which makes it possible to measure and compare the amount of green areas in different regions.
Assalamu alaikum, Maz here. The underlying problem that we are trying to solve with Shajr Stats is the environment has always been one of the most neglected domains of our government. One of the reasons for making Shajr Stats was having access to a web app that gives you instant stats on green cover based on satellite generated filters, which would mean that the users will be mindful of the fact that their district or city needs to have more tree plantations. Numbers create a sense of urgency and motivate you to do something about the issue at hand quickly. What we foresee is that the users of this app would be more eager to bring about a green revolution, district-wise, community-wise, and then eventually in the whole of Pakistan. Our web app is a one-stop solution for environmentalists, students, researchers, and government organizations looking to work towards planned tree plantations. This could be particularly useful for the current government's Billion Tree Initiative. Um, I would like to dive more deep in the use cases. Shredder stats can be used by urban planners to maintain certain level of greenery within each town. It can also be used for planned and coordinated plantation drives that are carried out by companies, by communities, and by groups of students. Uh, Moreover, it can be used for environmental research as an independent variable to study the impacts of temperature, rainfall, and humidity. Furthermore, it can be used for health-related research to study the impact of greenery on public health. Finally, it can be used by real estate businesses to identify properties that have parks, grounds, etc. nearby. Next slide, please.
All right, Assalamu alaikum. So the roadmap that we had for our project was basically, first of all, obviously since it was a data-driven project, so one of the major chunks of our time where was spent was regarding obtaining the data and cleaning it and making sure the data is fit for our modeling. So since it's a geographical data set, one of the major challenges we faced was since that Pakistan unfortunately does not have many satellite sources, and those that exist are not are proprietary and mostly in the hands of government officials. However, there are open source solutions available as Landsat, and that was our eventual choice. But even there are like platforms like Planet, which host a lot of good quality satellite imagery, but they are not pertaining to Pakistan. And even if they have the higher quality versions, it's very expensive for at least for us to actually conduct our research. So, and just obtaining the data was a very big hurdle for us to cross, because the modeling and etc. we can find material regarding it and do it using tutorials and stuff, but the data is the real crux of the issue. So that was where we spent majority of our time obtaining data and seeing if it's clear and seeing if the analysis can be done and whether it's useful or not. We finally settled on the Google Earth imagery catalog provided by the Landsat. It's an open source data. So that was our eventual choice. So once we had that data in, it was then we had to create a basically an ETL pipeline that will basically format the data accordingly to our needs and basically apply the relevant algorithms, which we will talk about later. So this whole process was basically carried out. So, for example, once we had the data loaded in, we needed to basically filter out the relevant regions. In our case, it's Pakistan, and then apply the algorithms. So the main algorithm that we were using is NDVI, and I'll just let Maz intervene, and he will tell a little about the algorithm.
All right. So the primary algorithm that we are using to detect the greenery is NDVI, which stands for Normalized Difference Vegetation Index. Um, Putting simply, NDVI is a measure of the state of plant health based on how the plant reflects light at certain frequencies, right? The negative values of this index uh, so the range of values of this index lie between -1 and 1. The negative values denote clouds, snow, and water. Values close to 0 denote rocky places and bare soils, whilst the values close to 1, like around from 0.6 to 0.8, they denote areas of substantial greenery, like tropical rainforests and areas with moderate vegetation, right? What we did was we did a binary classification between greenery, between a green area and a non-green area using a threshold value. Uh, so the values greater than threshold were classified as green, and the values lesser than the threshold were classified as non-green areas, or uh, uh, areas without having vegetation or tree cover. Then we use a reducer function to sum up the amount of green area within a particular radius. And lastly, integrating all this within an app, we deployed that app on Heroku. Over to you, Solid.
All right, so that will stop sharing your screen, and then I'll share mine, and then we can have a visual demo. All right, so Talat will have to enable the screen sharing, and then we'll proceed.
I have enabled. Can you share now?
Yes, it's visible. All right, so all right, so I'll get to this in a bit. Basically, one thing I really want to show you is the console that we initially were working on. So this is basically the Google Earth Engine console that we were using to conduct. So this is where the whole ETL pipeline was done. So I'll just give you a brief walkthrough. I'm not going to go it line by line because I'll have the demo as well. So basically, like for example, here we're shortlisting only the Pakistan international boundary areas, and then we are taking the corresponding cities using a fusion table, and then we have functions here like adding area and getting the relevant imagery and having color schemes set. So and having again a lot of pre-processing was needed. Like for example, one of the most essential pre-processing was removing cloud cover. So even though if you have green area, but if the satellite imagery is poor, especially in cases like Pakistan, the quality is not really that high and the images are very less, but still they can negatively impact the results, so you need to filter them beforehand. So once you're done, you basically get a collection of all the images, and then you need to apply the reducer function as Maz mentioned using a threshold value. And then we exported this to our image drive, and we got a data set as well that we used for our Python app. So again, a short overview of our Python app. It's currently running on Flask. It's a web server. So basically, um, the Python app is basically what it is really doing is it's pre-processing all the data and it's calculating all the green value areas and all the relevant metadata of province and city areas, and it's going to report back to the website, which is written using HTML and CSS. So I'll get to the interesting part then. So I'll just refresh this. So will take a while. So there are four key components to our website: the map, the analysis, and the relevant report, and our mission statement. So the map, which is what the crux of our result was. So here you can see a color coded area where it's basically showing the greenery percentage, and it's using a color scheme that is appropriate to the green levels of vegetation. So as you can see, the southern part of Pakistan and majority of Balochistan areas, as expected, are not very green. In fact, even if we try to zoom in into our relevant area, which is Karachi, we can see a little bit of greenery near the mangrove areas, but its majority, the percentages are very low, which is very alarming and which means that it needs to be catered to. Hyderabad and other areas are relatively more greener because they have less pollution, etc. But the majority of the area of greenery is taken NWFP and the bordering Kashmir area as well, including some greenery areas near Faisalabad and Lahore as well. But the majority areas were found over here. So the relevant metadata here is basically the city and the corresponding region they belong to, and obviously the greenery percentage as well. So we will view the results now. Again, some important metrics that we need to understand. I took the average of the entire data set, and it turns out that only 24% of the area can be classified as green covered. So that's even less than one fourth of the area, which is very, very poor if we consider countries like Germany, where the figure reaches around 80 and 90%. And the average temperature of Pakistan, obviously, part of this is also due to global warming, is rising beyond the global average, and our mean temperatures are constantly on the rise. In fact, 0. 0.5 degrees Celsius has been increased over the past 2 or 4 years. I'm stating that, but it's a very huge figure when you compare it to other countries as well. Also, to make matters worse, our air quality situation is very poor. We are ranked second out of 193 countries, and the levels of air is actually 6 times worse or 6 times above the threshold that the World Health Organization recommends, which is why planting trees is a dire need of the country at large. And now here we will see a distribution of the data as well. So as you can see, NWFP ranks the highest. And if you try to filter it down, so here we can see it's a level 2 segmentation. So first it was at the provincial level, then it's at the district level where we can see Hazara, Fata, and other areas there. And Hazara is the most green. And then amongst it, Aptabad and Manchera and Baltragam are areas that are highest. So to navigate this dashboard, we'll just click on the white background and it will automatically regenerate the chart with color codes. Let's go back and let's see what's happening in Sindh. Unfortunately, even here you can see Karachi is left behind and Hyderabad takes majority of the green area occupied in the region. And Hyderabad also has different third level town-wise boundaries, such as Badin and Thatta. Obviously, these are, and some there are anomalies, obviously, but obviously there are desert areas over here as well, which is why they have very low values, and Hyderabad and Multiari are taking the lion's share. So that is for Sindh. Let's also have a look at Punjab as well. Punjab, here we can also see Lahore is not leading, rather it is Multan that is leading, where Khanewal and Sahiwal, which are very famous agricultural areas, have majority of the green area. But here we can see the disparity is very less. So again in Sindh, we saw drastic differences, which is very evident. So Karachi and Hyderabad have a very, very huge difference, even though Hyderabad is also a very developed city. It shows that Sindh development is lacking very behind in comparison to Punjab and other areas where there is a difference, but the disparity is less. If we go to Lahore and we see areas like Kasur and Okara that come under this, they also have comparatively higher regions than the metropolis cities like Lahore, which is again signaling that our main cities, KLI, are lacking because of the urban pollution and the deforestation activities that have been carried out by the construction companies. So this is just a visual overview of an interactive drill down bar chart to visualize the data over here. So what analysis can we make above? So we did write a report regarding it. So obviously the results are similar to what I just said. It is basically saying the same thing, that Khyber Pakhtunkhwa is obviously leading, and then it's Punjab, and then Balochistan and Sindh are lacking behind. Hyderabad is again leading in the areas, but again we find out that Karachi is the need of the hour, and being a Karachiite ourselves, we were also worried in this regard, and this is one of the prime reasons that we are also trying to build these interactive dashboards so we can identify which areas in which we should plant trees with. So what's our mission? We did go over this. The what's next part will be covered by Talat in the next slide. Our purpose was again is just to basically have targeted plantation drives to save our resources and to have a data-driven approach so that even people can know that we can make informed decisions, not just based on bins and funds, but on concrete stats. The last factor is it needs to be audible and transparent. If we have dashboards like this, the government and the public can know that the funds, like for example, the tree project that Maz mentioned, we can know that where are the funds are going, with which plantation drives are they targeting, and we can see results, objective results. So we don't need to rely on word of mouth anymore, rather that we can see for ourselves. So I think this wraps it up for the demo that we have. The code will be shared to you as a GitHub URL. Thank you. I'll stop screen now.
Thank you, Soleh. So for uh, yeah, so our project has a lot of potential for future work. If you obtain soil quality data for different segments, we can actually use it to determine what type of vegetation needs to be cultivated in which areas. Secondly, if you obtain air quality index for each region, we can quantitatively study the correlation between air pollution and deforestation. Furthermore, overtime temperature metrics can also help us correlate plantation activities with climate change. Also, we can have real-time analysis of greenery KPIs.
I guess this is it. We hope that our web app becomes a driving force for mobilizing future tree plantations in Pakistan, that that our future generations can benefit from. Thank you.